Welcome back, students, to my channel Talking Physics with Piyas Sarkar. Today we shall learn about a new topic which is very important for our class 12 exam or JEE and NEET. In the previous lecture, we shall talk about half-life and decay constant. But today we shall briefly discuss the concept of average life and the relation of average life with decay constant and half-life. So, are you ready to listen this interesting chapter? So, don't wasting time. We will start it. What is average life? And how the concept of average life occurred? We know that in a particular radioactive sample, there are infinite number of radioactive nucleus. So, when a radioactive sample disintegrate or decay, some of nuclei decay very early or some of them decays at the end of the process. So, in general, it is impossible to predict the lifetime of every nuclei one by one. So, if anyone asked us that what is the average life of the nuclei, then we obviously take the average of the life of every nuclei. So, the average life in a word is the average time of all the nuclei before its decay completely, Okay. So, if we take or if we write the average life, so it is the sum of lives of all nucleus or nuclei by total number of nuclei present in the sample. Sum of lives of all nuclei by total number of nuclei. Now, how can we find the mathematical formula of average life? And what is the relation between average life and half-life? We know half-life is the time in which a certain radioactive sample decays to its half value from its original value. So, now we can go with the mathematical derivation of average life. Please take your copy and write it in your exercise copy so that you can understand it later. So, we can go with the average life derivation. Suppose at time t equal to 0, the radioactive sample, the number of nuclei present in the radioactive sample is N0, and at time t equal to infinity or t equal to t, or you can say t equal to t, the number of undecayed nuclei is N. So, in time dt, in time t to dt, if radioactive nuclei decays, number of radioactive nuclei decays dn in time t plus dt, so we can show that the life of each nuclei is t, because dt is very small. So, we can say that the life of each nuclei is t. So, the sum of life of total nuclei present in time t is equal to dn t into dn. Therefore, the total sum equal to integration 0 to n0 t dn. 0 to n0 t dn. Therefore, average life we can know that it is the ratio of the sum of the life of all nuclei, that is integration 0 to n0 tdn divided by n0, the total number of nuclei present at that sample. So, we can now evaluate the integration 0 to n0 tdn, 0 to n0 tdn. So, from radioactive decay law, we can know that n, that is the number of undecayed nuclei in time t, is equal to n0, that is number of initial nuclei at time t equal to 0, into e to the power minus lambda t. So, if you take the derivative dn, that is what we can get, n0 e to the power minus lambda t into minus lambda dt. So, minus lambda n0 e to the power minus lambda t dt, which is dn. Now, we can go with the integration of, integration 0 to n0 t dn. So, you can get 0 to n0 t, and the value of dn is minus lambda n0 e to the power minus lambda t dt. Here negative sign increase, I have already talked it in my previous lecture. If you not watch, please go to my channel Talking Physics with P.R. Sarkar and search that the radioactive decay law. This negative sign that implies that with evolution of time, the radioactive sample decrease. So, the number of undecayed nuclei is decreased. So, the negative sign is occurred. So, integration 0 to n0 tdn means minus t lambda n0 e to the power minus lambda t dt. Now, we can say that at or when t equal to 0, n becomes n0. When it is the radioactive sample does not start to disintegrate, n becomes n0, the initial nuclei, and when t equal to infinity, n becomes 0, because after infinite time the radioactive sample decays completely. So, we can get n equal to 0. So, integration 0 to n0 tdn becomes 0 to infinity lambda t n0 e to the power minus lambda t dt. We can neglect here the negative sign. Okay. So, here is the integration 0 to n0 t dn is equal to this factor. So, we can go with the average life, that is the average life which is denoted by tau is equal to 1 by n0 times this factor 0 to infinity lambda t n0 e to the power minus lambda t dt. Now, this n0 will be cancelled and lambda will be taken outside the integral. We can get 0 to infinity e to the power minus lambda t into t dt. Now, we can go with integration by parts formula. Okay. Now, we shall go with integration by parts formula. What is the integration by parts formula? If you know very well, if you not know, please check out the board. Integration u v dx is equal to u fixed integration of v dx minus integration du dx integration of v dx then whole integration dx. That is, at first we integration the second term keeping first term fixed, then put the negative sign, then we can differentiate the first term u and then integrate the second term, and we can then integrate the whole value. Finally, we can integrate the whole value. So we can get here that lambda 0 to infinity t e to the power minus dt. So if we put this formula, we can get lambda outside the integral and t, keeping t fixed, integrate 0 to infinity e to the power minus lambda t dt, then integrate 0 to infinity, then ddt of t, next again integrate 0 to infinity e to the power minus lambda t dt and whole integration dt. Okay. Before writing, first understand, then write. Then it will be easy to solve in the examination. Okay. Do not write it so quickly if you don't understand. So we can get lambda t, now integration minus lambda t divided by minus lambda 0 to infinity, integration 0 to infinity ddt of t is 1, and this term is integration minus e to the power minus lambda t divided by minus lambda and again dt. So here the whole term is 0, because if we put e to the power minus lambda in the space of t, we can get we put the value of infinity, that is the upper limit of the integral, then e to the power minus infinity becomes 0, and if we put the lower value 0 in place of t, then it will also be 0. So the first term is 0. So lambda 0 minus minus plus 1 by lambda, and this is again e to the power minus lambda t. Again we can get e to the power minus lambda t. So 0 to infinity. Now, sorry, here a lambda is also come, minus lambda is also come. So 1 lambda is outside the integral, and we can get minus 1 by lambda square. Now e to the power minus infinity means 0 minus e to the power minus 0, e to the power 0, that is 1. So this minus gives plus, and lambda, that is we can get finally 1 by lambda. We can get finally 1 by lambda. So tau, that is the average time of a radioactive sample, is equal to 1 by lambda, is inversely proportional to lambda, the decay constant. Now if we write the relation between half life, decay constant and average life, what we can get? We can get in the previous time that t half, that is average time, is 0.693 divided by lambda, and from this we can put it that in the term of 1 by lambda we can put it tau 0.693 tau, or tau equal to t half divided by 0.693, that is 1.44 t half. This is the relation of the three variables in nuclear physics, which is very important to derive any mathematical formula. I hope you understand the whole process. Now we shall go with the activity. What is called activity? Activity is the decay or disintegration per second. The number of radioactive nucleus disintegrate or decay per second is called activity. So we can get that R, the number of radioactive decay, is equal to R0 e to the power minus lambda t dt. Because from radioactive decay we can get n equal to n0 e to the power minus lambda t. Now decay is dn dt. If we take the value of dn dt, which is called r, then we can get n0 e to the power minus lambda t into minus lambda dt. So dn dt is r, that is the activity. Okay. So r equal to minus lambda n0 e to the power minus lambda t dt. Now r is minus dn dt. The value of r is minus dn dt, not dn dt. The value of r is minus dn dt. So activity r equal to minus dn dt, as the number of activity or disintegrant decrease with passage of time, so negative sign occurs here. So minus dn dt equal to r is equal to lambda n0 e to the power minus lambda t dt. Now lambda n0 is initial radioactivity at t equal to 0 time, that is r0 e to the power minus lambda t. So this is another relation for radioactive decay law, n equal to n0 e to the power minus lambda t. This is the another form of radioactive decay law in terms of activity, r equal to r0 e to the power minus lambda t. Now if we take here that r equal to lambda into n0 e to the power minus lambda t dt, this is known as n. n0 e to the power minus lambda t is n. Sorry, here dn dt term is not here because dt is divided here. So n0 e to the power minus lambda t is n. So we can say that r equal to lambda n, r equal to lambda n. So we can also know the two mathematical formula, r equal to r0 e to the power minus lambda t and also r equal to lambda n. Now we can go with the unit of radioactivity. There are three units of radioactivity. Number one is becquerel. Becquerel. If the the activity of nuclear sample is said to be 1 becquerel if there are 1 disintegration per second. So we can take 1 becquerel equal to 1 disintegration per second. If there are radioactive nuclei disintegrate only 1 in per second, then it is called 1 becquerel. Number 2 is Curie, in the name of Madame Curie, who was the inventor of radioactivity substances, polonium and radium. We can say it in the radioactive chapter in my video, previously video. So 1 Curie is written as 1 Ci equal to if there are 3.7 into 10 to the power 10 disintegration takes per second, then it is called per second, then it is called 1 Curie. So the activity is said to be 1 Curie if the decay of 3.7 into 10 to the power 10 disintegration per second takes place. Number 3 is Rutherford, that is RD, and 1 RD, if we write it as, this is the Rutherford, it is written as small d, 1 RD equal to, if the radioactive samples decays 10 to the power 6 disintegration per second, then it is known as 1 Rutherford. So 1 Rutherford, so 1 Curie equal to 3.7 into 10 to the power 6 into 10 to the power 4 disintegration per second. So this term 3.7 into 10 to the power 4, 10 to the power 6 means 1 Rutherford. Therefore 3.7 into 10 to the power 4 Rutherford. This is the relation between 1 Curie and Rutherford, and 1 becquerel equal to 1 disintegration per second, that is 1 Curie equal to 3.7 into 10 to the power 10 to the power 10 becquerel. 1 Curie equal to 3.7 10 to the power 10 becquerel and 3.7 10 to the power 4 Rutherford. So, in this way we can find the unit of radioactivity, and now we shall go with a numerical example so that you can understand it in a better way. Okay. So, before we go to the numerical example, we write some mathematical relation. At first, we get that n is equal to n0 e to the power minus lambda t, or r in terms of radioactivities, r equal to r0 e to the power minus lambda t. Number 2, t half is equal to 0.693 upon lambda, or 0.693 into mean life. The mean life or average. Number 3 is, as we go, that r equal to lambda n. And number 4 is most important to doing mathematical example, that is n by n0 is equal to r by n0, r0 equal to half to the power n, where n is number of half lives. So, this was the best mathematical relation to doing numerical example. So, the half life is the total time in which a radioactive sample decay to its half value, to its original value, or it reaches to its half of its original value. Mean life is the mean or average of all the nuclei present in a certain radioactive sample. Decay constant is it is a constant which is related to average value and mean value. Average value and half life is from this equation. And now we go with some numerical example. So, the question is, a radioactive substance decays to a radioactive substance is decays to 1 by 32 of its initial value. Of its initial activity, not value, initial activity in 25 days. Calculates its half life. Calculate T half. So, the question is, a radioactive substance is decay to 1 by 32 of its initial activity in 25 days. So, calculate the half value. So, we can know that R equal to R0 into half to the power n, or R by R0 equal to half to the power n. Now, what is R? R becomes R0 by 32, as it is said in the given example. So, R0 by 32 equal to R0 into half to the power n. N is the number of half lives. Then R0 cancel, we can say that half to the power 5, which becomes 1 by 32 half to the power n. So, we can get from here n equal to 5. That is, number of half lives is 5. So, half life. So we can get that half life equal to total time to decay divided by number of half lives. So total time to decay is what? 25 days. And what is the number of half life? 5. So we can get 5 days. So the value of T half is 5 days. Again, I hope you all understand it. Next, we will go with some numerical example. Number 2. Number 2 is the half-life of uranium against alpha decay is the half-life of uranium against alpha decay is 1.5 into 10 to the power 7 second. That is, emitting alpha particle in 1.5 into 10 to the power second, it becomes half of its initial value. What is the activity of sample? What is the activity, that is R, of the uranium sample having total number of atoms n equal to 25 into 10 to the power 20 atoms. So here we have to find out the activity of the uranium isotope, 92-238 isotope. So we can get the value of total number of atoms in that samples and half life. So as per the relation R equal to lambda n, we do not know the value of lambda. So if we put the value 0.693 upon T half and n, then we know the value of T half. So here T half is given 1.5 into 10 to the power 7 second, and the total number of atoms is 25 into 10 to the power 20 atoms. So we can get, if we put it in a calculator, we can get 11,550 disintegration per second. Disintegration per second. Now, if we say it that in terms of becquerel, Curie or Rutherford, then for becquerel it is 1.550 becquerel, for Curie it is divided by 3.7 into 10 to the power 10, and for Rutherford it is divided by 10 to the power 6. So in this way we can solve various numerical. So I hope you will get some new knowledge from my lecture about average life, decay constant and activity of a radioactive nuclei. Next day we shall go with alpha beta decay and nuclear fission and so many objective questions. If you like my channel, please subscribe and watch my all video till the end. Don't skip. Okay, thank you.